have salt. He had to use like a salt
Substitute, which is potassium chloride, yes.
Okay, and I guess I just never really understood like what.
Well, because he had heart problems
Yeah.
and or kidney problems, and he couldn't pee out the sodium that he needed to pee out.
Okay.
So the way to fix that is just don't eat it. And if you
Okay.
don't, but you still want something to shake onto your popcorn,
Well, he was like obsessed with salt.
Oh yeah,
So.
I hear you.
Yeah.
It's a real common problem. All right. I think we don't need to talk much more about sodium balance here. And let's just slide through this. Well, let's talk about hyponatremia for a minute. Hyponatremia means it's low sodium levels. All right, now you can have low sodium levels for two reasons. Number one, you don't have enough sodium, or you have too much water on board that's diluting it out, right? So always keep those kind of things in mind. Hyponatremia is when your sodium starts getting down. Once it's less than 136, we said 140 is normal. When it gets lower than 136, it's on the way. Hypernatremia is just the opposite. It's when usually most people who get hypernatremia get it because they don't have enough water to dilute it. Okay, they lose water, and therefore their sodium gets really concentrated. Once it gets above 145, that's what we call hypernatremia. If it gets to 160, you are really, really sick. Yes?
So if you're exercising, like you're not an athlete, you're just a regular exerciser, you really shouldn't be drinking sports drinks then? Because it's kind of doing like the opposite of what you want it to do?
Well, I think there's been fortunes made on sports drinks. And the reason is because they contain two things. They contain sugar and they contain salt. They put enough sugar in it so you can't taste the salt, because nobody's going to sit around drinking salt water, right? That's really all they are. Now, do you need, if you're just a regular athlete, do you need extra salt? Not really, because 3 hours later you're going to eat a meal and you're going to get all kinds of salt. So I think that sports drinks have gone way too far, that people think they have to drink it because, you need that sodium. No, you don't. You really don't. They also have a little bit of magnesium in them. They have a little bit of zinc in them. But it's pretty much marketing that makes you think you need that stuff. So just drink water. Your meals are going to contain all the other stuff you need. Extracellular volume. If your extracellular volume is inadequate, you don't have enough fluid inside your system of your plasma. Your blood volume is going to go down. Your blood pressure is going to go down. Once your blood pressure goes down, you're no longer sending enough blood to that afferent arteriole, right? If you're not sending enough blood to that afferent arteriole, you're not making enough filtrate, and your body's going to turn on the renin-angiotensin system and start fixing all of this. So everything relates back to all of this stuff pretty quickly. Potassium balance, remember that 98% of all the potassium in your body is inside the cells, in ICF. We spend a lot of energy pumping that potassium into the cells. Enough said. How do we maintain potassium balance? Well, once again, it's mostly just we absorb it, and how much do we lose in our urine? We can control the amount of potassium that we lose in our urine. So those are the ways we control potassium balance. A few terms you ought to know. You really ought to understand what these things mean. I think we've talked about most of them here today. I'm just going to let you refer to that yourselves. Yes, ma'am?
I keep twisting in my head. So it's like the more hydrogen you have is the more acidic you are, correct?
Correct. Right. Because let me make a basic science teaching point here, if I could. We just said that pH, the definition of pH is equal to the negative log of the hydrogen ion concentration. Okay? Now let's just say that the concentration of hydrogen ions is 10 to the minus 1, which is 1/10. Okay? In other words, pretty much a lot of acid if you've got 10% of your, well, if that's your concentration. If it's 1/10 of a milliequivalent per liter, that's really kind of a lot. And you do the negative log. In other words, what's the log of 1/10? Well, it's 1/10 is minus 1. Okay? Minus 1/100th. I mean, 1/100th. 1/100th is minus 2. That would be the log of 1 over 100, because 1 over 100 is the same as 1 over 10 to the 2, right? So as the number gets bigger here, and it becomes 1 over 13, for example, okay, which means it's a pretty low concentration. Now it's 1 over 10 to the 13th, very low level of hydrogen. pH would be 13.
So it's basic.
Well, in 13, it's going to be very basic. There's going to be a whole lot more bicarb than there is acid at that level. Just got to remember this concept right here, that pH is the negative log of the hydrogen ion concentration.
More hydrogen, more acid.
More hydrogen, more acidic. That's correct. Okay.
Thank you, Howard.
Yeah. I'm done. Is that all y'all have on your lists?
No.
You got more?
You get to half the chapter.
Really?
Barely half the slide, there's 100, you're on 60.
Oh, here they come. We're coming. I'm sorry. We didn't get through half the chapter. Boy, that breaks my heart. All right, here's an acid-base equation you need to remember, because we talked about this one at length when we were talking about the respiratory system. Remember that one that was H2O plus CO2 forms what's this called? Carbonic acid, which then can break down into H, which is acid, and HCO3, which is basic, bicarb. So, depending on which way this equation shifts, we can change and correct for problems. Obviously, we can get rid of H2O pretty easily out of our body by even just breathing it out. We can certainly get rid of CO2 pretty easily and push the equation that direction. Same thing can go back this way too. Why do we need to control our pH? Well, it's because we have everything in our body works only at one pH, and that's really very narrow range here between 7.35 and 7.45. If once you get out of that range, nothing works very well. None of the enzymes work, none of the chemical reactions work, and so we do struggle to keep our pH normal. What is an acidosis? An acidosis is when our pH gets below 7.35. What's an alkalosis? An alkalosis is when we get above 7.45. That's a pretty narrow range to be working things at. Acidosis and alkalosis affects all of your body systems, especially your nervous system. Both are very dangerous. Acidosis is more common. Why do you think acidosis is more common?
Your stomach.
Well, your body's not making bases.
If you breathe too much oxygen, like you hyperventilate.
Well, if you hyperventilate, what's that going to do?
Blows off extra CO2.
You're going to blow off extra CO2. You're going to become acidotic or alkalotic.
Alkaline.
Alkalotic, yeah. Well, acidosis is much more common, I'll just tell you. And the reason it's much more common is because our body is making acid all the time. If you're in the hospital and you're walking down the hall and you get pain in your chest and you fall over, okay, and you go into cardiac arrest, and the nurses and everybody arrives about 2 minutes later and they start resuscitating on you, and they start CPR and they start breathing for you, your pH is probably already down to 7.1. You've already, in just 2 minutes, you've dropped your pH from 7.4, where it should be, down to about 7.1. And the reason for that is every chemical reaction in our body is making acid every second. And when we quit breathing, and that's what happens when you have a cardiac arrest, even if you're still breathing, you're not moving blood past it, so it's not doing you any good, right? You get acidotic very quickly. One of the first drugs they're probably going to give you is some soda bicarb to try to raise your, which is basic, to bring your pH back up so that maybe they can get everything running again and get your heart beating again and so forth. But acidosis is very common, and it comes on very, very quickly if you're not breathing properly. PCO2 is the most important factor affecting pH in the body tissues. Why? Because it can change so quickly, like I just said. If you're not breathing and you're not blowing off your CO2, you become very acidotic very, very quickly. You can almost say that PCO2 and pH are inversely related. We'll talk about that more when we get to some little cases here. All right, I think we'll stop at this point and move on over to the lab. I think I will try to finish up this lecture over there because there's really not all that much lab stuff, as you guys have figured out, in this chapter. And that's why you're so worried about the physio X's.
Yeah.
Yes, ma'am?
Do you want the
Chapter 27.
do on Wednesday?
The worksheets. Yeah, you can just Wednesday. Let's bring them Monday.
Monday?
Second day. Yeah.
What are we doing? Case studies?
No, not the case studies. You don't have